our introduction into cylindrical coordinates, I've pulled up a Geogebra applet that I like to use to show or illustrate how the points are plotted. The good news for us is that we are familiar already with polar coordinates, and it turns out that really cylindrical coordinates are no different than polar coordinates. We just add a vertical component to it. You see we've got z equals 4 as our particular point. The coordinates always come in the form r comma theta comma z in that order. And you can see here we've got r equals 3, we've got theta equals 2, which is measured in radians in this particular app, and z is equal to 4. As we sweep this out, we know polar coordinates, r equals 3 is going to be the radius out from the pole, theta equals 2 is going to be the counterclockwise rotation, and of course we're going to add this vertical component, which is what makes it cylindrical coordinates. So if we plot this out, here is our radius coming out 3 units. We are going to sweep out an angle of 2 radians, and then we're going to rise vertically to a height of 4. And if we go ahead and show the cylinder that we're on, the idea here is just to illustrate that we're on a cylinder and that this is why we call it cylindrical coordinates. We can kind of play around with the height. You can see that we remain on that cylinder. If I change the angle theta, again the point remains on that same cylinder of radius 3. Of course we can change the radius, which just changes the diameter of our cylinder. So again, we have our familiarity with polar coordinates already. All we're doing is adding a vertical component to that to create what we call cylindrical coordinates.